Welcome to our channel for probability and statistics. In this video, we will talk about confidence intervals, prediction intervals, and tolerance intervals. So it's very important to emphasize the difference between these three types of intervals. So they are confidence interval, prediction intervals, and tolerance intervals. For the confidence interval, one is interest in the population mean. So in frequentist statistics, a confidence interval, also called CI, is a range of estimates for an unknown parameter. A confidence interval is computed at a confidence level. So usually, for example, 95% confidence level is very common. But for other levels, such as 90% or 99%, are also used. So the confidence interval, or say the degrees of confidence or confidence coefficient, represents the long-run proportion of CIs at a given confidence level that theoretically will contain the true value of the parameter. A tolerance interval, or say TI, is a statistical interval within which, with some confidence level, a specified sampled proportion of a population will fall. So more specifically, a 100% times 100 1 minus alpha tolerance interval will provide limits within which at least a certain proportion of the population falls with a given level of confidence 1 minus alpha. So tolerance interval will be connected with tolerance percent, also with a confidence level. So say we have a confidence level to accept this percent of a range which will be accepted. So it is a more industrialized prospect for the tolerance interval. It is mostly used in industrial. We accept such level. Outside of this tolerance interval will not be accepted for the products. And for the prediction intervals, it is most widely applied when it is important to determine a bound of a single value. So the mean is not the issue here. Because we do not know the mean, sometimes the variance of a single prediction interval will be wider than the mean of a sample mean. So next we will take a look at an example. So for the machine quality, a machine produces metal pieces that are cylindrical in shape. The sample of these pieces is taken and the diameters are found to be these 8 numbers in centimeters. So use this data to calculate 3 interval types and draw interpretations that illustrate the distinction between them in the context of the system. So for all computations, we assume an approximately normal distribution, and the sample mean and standard deviation for the given data also known. So the question A finds a 99% confidence interval on the mean diameter. Question B, compute a 99% prediction interval on a measured diameter of a single metal piece taken from the machine. Question C, find the 99% tolerance limits that will contain 95% of the metal pieces produced by this machine. So the solution is, for A, the 99% confidence interval for the mean diameter can be given by the sample mean plus minus t 0.005 times s divided by square root of n. So here t 0.005 is the critical value for the t half alpha, because here alpha is 1%, and s for the sample standard deviation. So in the end, we can get the 99% confidence interval bounds are 0.9781 and 1.0331. So the question B, the solution for the 99% prediction interval for future observation is given by sample mean plus minus t 0.005 times s times square root of 1 plus 1 divided by n. So here t 0.005 is the t critical value at t half alpha. Here alpha is 1. And in the square root, we use 1 plus 1 divided by n, because here we want to predict a single observation, a single future observations prediction interval. So it is more random than the population means confidence interval. That's why we add 1 here in the square root. So the result is 0.9186 and 1.0926 for the bounds of this prediction interval. So you can also see these bounds as wider than the 99% confidence interval for the population mean. So the question C, for the tolerance interval, we have to check the table for the tolerance interval, find n equals 9 and 1 minus gamma equals 0.99 and 1 minus alpha equals 0.95. So we can find k equals 4.55 for two size limits. So we can say the 99% tolerance limits can be given by the sample average plus k times s, which equals 0.8937 and 1.1135. So we can say we are 99% confident that the tolerance interval from 0.8937 to 1.1175 will contain the central 95% of the distribution of diameters produced. Thanks for watching and subscribing our channel.